associate professor at Howard University, and we're here in person with him to see the campus. Is in the Department of Pediatrics and Child Health at the College of Medicine. And he'll be talking today about metabolic disorders and also just talking about how we can work more together with Howard University. And so I welcome him on campus and look forward to hearing more about what they're doing at Howard and how we can work together. So thank you for making the time to come all this way.
Thank you, Dr. Mara. I mean, it was very fascinating for me and very mind-boggling because I have passed through this institute at least 20, 25 times, but I never get into. I mean, I should have get into earlier than today. So it's my pleasure. It's my honor to be here before all the August audience. And we will share some of the information about what we are doing at Howard. And that is why I choose one of the very, intriguing topic, the metabolic dysfunction that the whole world is suffering. Not only the whole world, especially the people of color are mostly affected around the world, especially in our area too. So I try to make it more interesting to the general public audience, and at the middle, at the end, we will also go into some of the interesting findings that we got with our study. So let's get started. So now we are seeing that I will discuss the diabetes at a glance. I mean, this diabetes now, I think, become a household story everywhere. And let's see what is a global view. And if you see the map of it, and now that we are in the North American or Caribbean side, it's a 51 million people. And also, if you see the very down south, that is where the Southeast Asia, that is also one of our target areas, and they are becoming sometimes a key areas of having type 2 diabetes or metabolic dysfunction. That is Southeast Asia and Asia, and mostly like India, China. What is the staggering cost? It's mostly $1 trillion. So if it costs our economy and it's cost individual expenditure, and it has increased about 360%, which is it is really out of the sky. And from there, and say for what is the disease status in USA of the metabolic disease? If you look into the map, how it looks like in the left-hand corner upper side, this is a map for the Hispanic whites. And if you go by the color, you can see that you can hardly see any dark chocolate color, means those who are 45 to 50% in between. But if you compare that curve, that map, and where we compare only in the upper right, lower right, with the non-Hispanic blacks, and you see how the big difference in the colors. And mostly it's become more than 40%, half of the states beyond 40%, and highly you can see in the yellow states, which is less than 25%. And Washington, D.C. area, particularly District of Columbia, I mentioned, it is already more than 40% of population, which is have a problem. So, and compared to this area, now what we are talking about, the key area is now the Southeast Asian countries, how it looks like. If you look like that, and India is in the top right now, except the China, and hopefully this will be the capital of diabetes now, followed by these are the top 7 nations. In the top, India, Pakistan, we have worked on it. I will show some of the information about that, what we worked, and it is going up. And however, it is 2009, I think it has more than what I have been projected over here. So this is the real 2021 information. So 90 million. So it was the adult living with diabetes. 2 in 1 means 50% having diabetes are undiagnosed. That is a real key. Because most of the awareness and the detection is not yet reached to the very grassroots level, and it's 1,000 caused by diabetes in 747 per 1,000. It's a very high numbers. And you saw, if I go by the figuring or the number of US dollar 10 million spent on diabetes, which is far less than of it. But this is some of the key numbers over there. And then now the question arises, why there is a sudden increase of this disease around the world? So we thought there are some key players behind it. That means that we are always being exposed from the different kind of environments, either from the food, chemicals, whatever you thought of, that is being diffused in the system. And we are, as the population is becoming much higher, so we have to depend on more on pesticides to grow more foods, some use of some of the personal chemicals and other influences of other toxic chemicals in the rivers have gone up. So these are the key factors that has changed over time during last 3 or 4 decades. And one of the things that even if we are not born, even if we are in the mother's womb, that is, we are very careful about that. So these are the toxic materials that comes through the placenta when somebody is carrying babies. So that is why we are very much skeptical about that. Why we are very much careful about taking ingestion of anything and about the exposure. And it has been exposed to get through the ingestion, inhalation, skin uptake, depending upon the nature of the chemicals, as well as the amount also varies. So how the notion came in, so if you are being exposed of some of the chemicals, we call it endocrine disrupting chemicals, that acts like a hormone, because I know Baltimore area, around 2000, 2003, were being exposed with some of the benzene and benzene-related chemicals. And because we know we have so many manufacturing chemical units over here, so one of our scientists worked with it, and they showed it, and some of the chemicals have a key role in developing some, what is called congenital heart diseases in this area. But our area is some of the endocrine disruptive chemicals that is mostly used as the pesticides or the fire retardants. And if you have exposed earlier in your life, you may get into the late phenotype like obesity. That is one of the precursor of the disease of type 2 diabetes, and with the many different pathways. It could be change in the hormone and lipid metabolism. It could change in your early BMI, change in the birth weight, and some of the adipocytes, the lipid depositions. And some of the DNA methylations we also talked about. And this is the one quick examples I like to cite that is being made by the Hamilton in 2002. Is it looks like as we developed through that era or the different from 1993 to 2000, this scientist shows that the number of synthetic chemicals production increases over time. Our percentage of overweight adult also increases. So they make a indirect conclusion or the communication that use of the chemicals over the period of time might have an effect on the overweight people. And that is what it happened, those excessive use of the chemicals through different lifestyles, through some of the exposures, and through daily eating habit might have caused that. And as you see that it is not a very easy process, or we cannot blame any one of the causes. It's a complex process. So that's why it cannot be judged by people like me, only one who is looking into the genes and others. We need a social environment. That it means we call nowadays is a science of the total environment. It means where you live, how you eat, how you're being exposed, how you're taking into action, whether you exercise. So all these complex information or the effects get into our physiology or the biology, and then you have developed your disease or the how you interact with this all the informations or the effective. And with all this one, and we over the years we said that nutrition and diets, this is very important in diabetes, because this is a very talked about subjects and what we should look for if you have a diabetes. Basically, we call it ABCs of diabetes. So we need to know this is a very layman's information. So what is diabetes? Basically, we ate food and we get the glucose. That is a key for our cells to get the energy. And insulin is basically the carrier which let the glucose into your each of the cells. And if the insulin has a problem, then all your cell is deprived of glucose and your glucose level increased in your bloodstream, and that is how we get into the disease. It could be, very of them that feed type, basically type 1, which is mostly happen in the children between very lower percentage, but mostly we heard about the type 2 diabetes, a very common one, that is insulin resistant because of the the not breaking down or the problem in the insulin, which is most common. Another type of diabetes you might always heard. This is called gestational. During the pregnancy it happens, but normally it goes away. It is a short-lived one. How we diagnose this one? Normally, these are the right side in the boxes. We showed that is the symptoms. That is how whether you might have a diabetes. And if you have diabetes, you get diagnosed. Basically, if your random blood sugar is 200 milligram per deciliter or higher, and you have all the signs, then you have a diabetes. Or if you are fasting blood glucose, like if you wake up in the morning and you get tested, if it is 126 milligram per day, you have a chances of that diabetes, but you have to take it for consecutive 1 or 2 days. And if it sustains, then you should see the doctor. And also, this is the one key thing, that's the hemoglobin A1C, that reflects that what is the average blood sugar level in your last 3 months. So if it is 6 nowadays, it is a 6.5 to 6.7 or higher, you have a high chance that you are in a diabetic zone. Also, sometimes we had to do the 2-hour glucose tolerance test. That's when you go to the clinic. The physician recommended that, but to say the status of how you absorb the glucose, or how much of the glucose is coming into your blood. So these are the possibilities. And how we monitored. This is basically nowadays is the gold standard, HbA1cs. That is, it should be below 7 if you are diabetic, and the targets are, and if it is 8.5, it is still acceptable. You have a high serious chronic conditions or on a limited time, or maybe the later stage of your life, but you have a diabetes, even that you have to maintain below 8.5. That is accepted, but 8.5 is a very high in the general sense. Blood sugar versus blood pressure, that is also another key we looked into. Blood sugar target is always, if you have a between 70 to 180, depending upon the fasting or the postparental. Also, the blood pressure target is always has to be 140 by 90 if you have no heart disease. And if you have some heart disease or any other cardiovascular system or problem, then your blood sugar should be much less than that of mentioned earlier. That is 130 by 180 only. And definitely the cholesterol is also a target. So your cholesterol target, LDL should be less than 100 milligram, triglyceride is less than 150. HDL, good HDL means it's a good HDL, the more than 40. And HDL in case of female, it is much higher, 10 points higher than of the male in the regular process. So now, how the diabetes is treated? Besides the medicines, I think nowadays, diet and exercise is coming into a very focused area. First, let's go to the diet. That is D. Something has changed over the time in this country. Not this everywhere. Our portion size has changed. If you could recall those, like me, 20 years ago, chicken Caesar salad sold having 390 calories in it. And the key is your calories in and calories out should be balanced. It means how much energy you are taking in, it should be burnt out in the way of your life. And nowadays, if you see that the Caesar salad is selling, it's more than 3.5 cup, which has a 400 calories of differences. So now, how you want to spend it? You need to get it spent. Otherwise, you will have a caloric imbalances. So say, for example, if you have a 160-pound weight, what you need to do? You need to do an extra 1 hour, 20 minutes walk to spend that extra 400 calories you took into, and depend and see that every extra calories, how much minutes of work you need to do, extra one, besides your regular work. And also, if you talk about the muffin, I'm giving another example. The muffin 20 years ago, now a muffin from a Sam's Club or big one, how is calorie imbalances? It's a calorie imbalance of more than close to 300 calories. So to expend the 300 calories, you have to run a vacuum for 1 hour, 30 minutes in your home to every 290 calories. So we have to be very careful about the diets, what our caloric need is, and what is the age, and how we spend the calorie in the meantime. This is what we talked, it is called myplate.gov. That is a recent information that you might think about the changes in your lifestyle in the diets. This is one of the key factors. In the red, you will see that instead of 4 short-bit cookies, you can think of medium apple, which is unhealthy. Green is unhealthy, and red is and see, for example, like 1.5 ounce of milk chocolate bar, instead of that 230 calories. So they can chop down. So you have the opportunity. And if you visit that place, choose myplate.com, it has, you can interact with that. So if you take this much is high, where I need to, communicate, or how I need to negotiate with the others to get it down so that my calorie balance is maintained. So that is a very important nowadays. And exercise, we talked about that you need to have at least 150 minutes per week. That means 30 minutes over 5 days. It's an exercise. You can use a pedometer, and I put a calculation. This is from the web, so that how much, and do not over exercise. Sometimes here's a problem. Depends upon your weight and how you want to. Heart rate have to calculate. If there's a calculation is there, so it has to be measured exercise per week, and it's a 30 minutes, and it depends upon what your body weight is. So if you want, that is a key thing. Say if you have to reduce the risk of developing diabetes, or if you have diabetes, you should have a healthy diet and a healthy lifestyle. What it means, you have a healthy diet. We have some examples before, and definitely the fast foods, really that is a big problem, I know. And exercise often, definitely you have to quit smoking. And I will come to the story about it, and you will find that story a little bit. What is a smoking problem in this in Washington DC area? Either if you are smoking, quit smoking, and don't start. And reduce stress. This is a big area now. The problem is stress is another key issue, which it can make a heaven and hell difference in your blood sugar. So, what is called meet the challenges head on, exercise, relaxation, and relaxation techniques. It has to be. You have to get rid of stress. It's very hard to. It's easy to tell. I know how hard it is. So stress is another big issues in this population, and definitely overall. So let's look at with this background of information, what we are trying to do with our knowledge as a investigator. I pose myself and my team myself as an investigator, because something is happened or happening. We need to find out why it is happening. So basically, we are an investigator team, and research gives us a tool to find them out. And what research means, and I have quoted 2 of the finest people, I think, in the world. And if you do not know about the third person, Ahmed Zawali, I think he was a born Egyptian American, and I think she got the Nobel Prize in the invent of the laser techniques. And if you see that what research means, and I personally think this country become the top because of this. It outstanding research facilities and research innovation and the investment get this country into the top. The very first and the very last example I can take about that research that we took the fruit of it is the COVID vaccination. We had made the COVID and COVID, how it can be delivered. It is being made, we know about it 50 years ago. It's just a matter of time. I think within 1 year or so, it is the most successful and fastest ever possible vaccine in the world, I think. So science has a big, in the research, in the investing in the future of the country. So with that note, let's see what we work on. We work on the early disease, because if you had already got the disease, now it's the only verification is get the treatment one. Our target is because before you get into the disease, is there any way we can find out that you are in the track or you are in the risk? So before we get it started, I want to give you a quick example how we get into the early disease one. So the story started back in 1865, I think, when we talk about that it's a part of the genetics when Gregor Johann Mendel talked about those possibility of the dwarf and the peat flea. What will the ratio? And it took about 135-40 years when another breakthrough when Watson and Crick discovered that DNA structure is unfolded, is a double-stranded. And it takes another 60 or maybe 50 years, the human project is completed with a staggering cost of 3 billion plus. And after this human genome project is completed, the whole notion of the biological science has like a big change. Previously, you get disease, and then you get treatment. Now that disease is looked into the way of prevention, and that is made possible because of the human genome project completion. That means your whole genome is mapped. It's not only the human genome, it started with the human genome project, and I think nowadays every important animals and the plants are being mapped so that we can look into where is a problem. And we took some portion of it to know about the disease and disease happening. And that is what it happens. The Human Genome Project gives a very solid foundation of the modern genetics now, what we are looking into. And it is a publication of Dr. Francis Collins, who was the director soon after the publication of the Human Genome Project in 2003. This is one of the current, not the current, it is 10 years old, but it makes a sensation in this country. And I hope you have known this lady who is on the left, Angelina Jolie. I think we call it, the Times Magazine came up with the story of the Angelina effect. And what the story it is, if you are mostly might have known that her mother died of breast cancer. And her grandmother also died of breast cancer. So she has some doubt, or she has some fear of getting into the breast cancer because it is running into the family. And by the time we know the BRCA1 gene, which is a very prominent most in African American, and BRCA1 and BRCA2, that's an indicator of having a risk of having breast cancer in the future or not. So what she did, so she simply does a gene sequence of the BRCA1 and BRCA2, and that is what at that time it cost around $1,000 or so, but nowadays it can be done within 180 or 250. It's a very normal screening now, and I think you see that what it costs to take the whole genome screening to get into the run now. What the technology moves in, and after that sequence is done, the results comes up with that she got a 57% of chance. The analytics like people who knows statistics and bioinformatics, they come up with the notion that, oh, you have a 57% of chance of developing breast cancer in the future. So she took the decision that she had a double mastectomy, and it has a sensational time in that 2013. And if I recall well, after that, I think previously it was mandatory or not, insurance covered, recommended mammogram after age of 45. I think after this story, there is a big, now the insurance are taking care of that. You can have the mammogram done as early as 40 or even earlier. So that is a story. And this is made possible of all the invention of the genetics and the research behind the genetics. So we took that advantage. And so basically what it does, so if you have some unanswerable question in your mind or hypothesis, you can have the array or sequencing done by the statistical analysis or any who has a very good at statistics. They can lead into the cancer, what Angelina Jolie had. But we are the biologists, we are not tough or the very good at statisticals, unless Dr. Lee is here, who is taking care of some of the statistics from our work. We do the functional analysis called the biological interpretation as a biologist, and we put the same data into our same interpretation, and we reach into some answer. So that is a way or the logic we are working on. To get into that one, I will give you a very brief information about the PCB superfine site story. If you recall the story of PCB Hudson River story, it happened 30 years ago, and maybe 1997, where there is a spillage of, not the spillage, is a purposeful disposal of PCBs in the upper Hudson River, which flows all the way 200 miles of Hudson River all through the New York, and it's created havoc in the population who are basically eating the fishes from this river and got illness. And in EPA took a story of that one, and they took care of it. And I think G, that is, they're making that, what is the incinerator, they're making the same fine, and they're and the cleaning process. And if you see how the cleaning process is. With the same story, I will come up, that is the people we work with. We call it PCB exposure in the Slovakia. I think if you see on the left side, this is illustration given by artists. That's how it's a harm's way. That is how the toxic effects can you get into the fetus in the world, and what are the main problem that a child can happen. That is IQ deficiency, learning disabilities. And there is all that we talked about very early, that is your external exposure of endocrine disruptor through the mother soup to the fetus or to the children. And if you see this, the map of the Eastern Slovakia, that the people we work with are basically the children we work with. This is Eastern Slovakia, and which is a very healthy, mostly the white population. And this area is the Mykolaiv, that is the city. What had happened during 2001 and between 2003, the children, those who are born in these local hospitals, are becoming underweight, and they do not pass the very what is called the test, IQ test and others, which is being taken up soon after the birth. The physician was worried about. It never happened before, because basically this area is very healthy, and they do not find any problem in their blood work and nothing else. And normal blood work, everything was normal. But one of the collaborators we worked with, Dr. Thomas Tonavre, he was basically a physician, but is basically the environmental medicine specialist. He had some hinge because he worked with those PCPs earlier. So he sent the blood to the Swedish lab. We call it Ake Bergmans. There is only two places this PCB can be directly measured from the blood. one here in USA in the east west coast in the Parks lab, and this is when the results comes in. They cannot believe the figures. This is now the highest ever PCB exposed people in the world. And they are sometimes 5,000, it's like around 5,700 nanogram per gram of lipids. And so what did happen then when this PCBs comes up in this 2003, there is no way because PCB is banned in USA 1971. And I think it was banned worldwide and in the Geneva Convention in 2000. So how come this people, there must be some exposure. So what they did, they check their mother. Basically, then the mother also had the same high exposure of the PCBs. Then how the mother get the exposure? Because there is no PCB plant nearby, nothing is exposed. So they track to what they eat and what they do. So basically, they track their food. They basically does this country, Eastern Slovakia country, they love the cheese and others, fat type. So they came out from the fish, local fish, poultry feed and poultry product, cream cheese and everything. And they track this river, we call it Lovorok River. If you see this one running from very top, Stachke, there was a chemical plant, this one. They were producing the PCB as a byproduct, and what they're doing, they are dumping their byproduct in the foothills. This is the almost 200 kilometer away, means 160 miles, something like that. They're dumping those chemicals in the night for not 1 year, 2 year, or 20. It's 20 years they're doing so without any knowledge after it is being banned. And with the passage of time, it flows all through the river, it gets into the ecosystem and gets everywhere. And then slowly how it becomes landed over here and it gets into the region. We work on those population. We are very fortunate that we looked into that one. And those are the children of 45 months. We took care of it. We got the blood from there and we analyzed their blood with our gene expression studies. And some of the results will be coming. So this is our work plan. So basically, when they are born, so every during the birth, at the 2 years and 46 months, and also we had samples of up to 7 years. These children are followed longitudinally, and each longitudinal time point we had the blood work. We had an opportunity to work at the blood from the birth and as well as 46 months. And now these children are becoming adult. They are adult now. So we are planning to have these checked one more time. They are around 1,043 mother pair cohort. So they're following these children all the way to this 2023. So we are planning to work with them. So what is the status? What we resulted from the 46 months, and what was the result? And we use I am not going into that one, that we can do it in a different day. So we note the pathway analysis for the blood exposure or the gene expression. And there is some other way we can look on, but let me see what we get into that one. So we did some of the mechanistic study with the in vitro study and also the 45 months study. So if you see this endocrine system disorder, this is becoming the top in the assessment. Endocrine system disorder, that definitely it should be because that PCBs are attached to your endocrine system. And also, if you see, we had a very small indication of having cancer in the in vitro study. So basically, what we did expose the human life cells, the PBMC cells, with the same or the mimicking the structure, the exposure structure of the Slovak population, and we get that disease annotation or the explanation that it may happen. And if you see this 45 months, it's almost the same, some of the reproductive system disease that is already there reported. And you will see that the cancer incidence is coming up. We had a hard time. We proved that one, we published that one, but we had a hard time to prove that PCB makes cancer. However, it is a category 2 cancer producing agent, but PCB, if you say PCB produce cancer, they might have some issues in their local area. So we do not say directly, but we indirectly probe that if those are exposed that time, in the future, they might develop cancer in their lifetime. This is one of the published in 2018. That's how the complex network is on those children. Those are 45 months old. And if you see, this is mostly the cancer mechanism overall, but none of them are cancerous, or they do not have, they are children. How can you expect 45 months? But most of the central molecules that we found, this is the TP53, NFK-kappa beta 3 kinase, also the MYC one over here, they are the key player, even they are at the, so we indicated if this network or the interaction of the molecules goes on over time and time and time, they might have a chance to develop a cancer. So we made it successful in 2018 to get this published, that PCV cancer possibilities. And also we made some validation through the high density array. And that is one of the concepts, that is, if you have the exposure, the same hypothesis, how it can develop, these people or the children can develop metabolic dysfunction or type 2 diabetes in the future, or any other disease, obesity. So we use the techniques, this is very common to us right now, the QRT-PCR system, and we can inspect the gene or a group of gene of a particular disease. And this is how it looks like, some of the expression pattern we try to communicate with the expression or their exposure level. So we try to develop some markers. So these are the key genes, LEPR, ARNT, RRAT, in those children. Those are responsible for, the metabolic disease or diabetes related condition. And some of the genes we also find out that also becoming the key in our adult population too. And it will also give a quick glimpses of the idea. So how the group of exposure in those children, depending on the list of key genes that we mentioned over here. And you can see the pattern of exposure, if we consider the high exposure versus low exposure group, is different. So we are in the process whether we can communicate with the exposure biomarker with any disease or any particular gene, so that that is what we need, a lot of more subjects to do that one. And what we published and some of the others, so it is not that we are talking about some of the other worker that PCD caused the diabetes and the obesity, that is a precursor, that the exposure make a possible polychlorinated biphenyls. And diabetes is one of the key diseases that they come up with, that we already postulated, and people are also talking about this one. So environmental exposure is one of the key in getting into such metabolic dysfunction in the future. And now it comes to our local area, what we talked about health disparity and health disparity issues and African Americans. So specifically now we are slowly moving to the current project, what we are doing at Harvard, and African Americans in Washington, DC area. So in that project, to inspect some genes that are responsible from the major diseases in African Americans, we included or recruited around 400 subjects from that Washington, DC around, mostly are in the DC area. And we inspect the 54,000 gene transcript in each people. And we ran the analysis part. And from that 54,000, some of the, you see how we get into the numbers 500 to 700 over here. Gene transcript, that we thought they are the significance or to pass the or filter criteria. And then out of this, after we ran the IP analysis, we come down to a 24 gene transcript. That is the key. And again, when we ran our validation by pilot studies, out of 24, we are narrowing down that those who could be disease specific has a direct correlation with their disease condition, and that can match with any other criteria of their covariance in the particular. So that is what the T8 genes transcript now we come up with. Some of them are, you see that T2DM and DM related. Some of them are cancer related, and very few of them are neurobehavior related. We didn't knew that earlier, but we came to know that if you have a chronic type 2 diabetes for a long time, you have a more prone to develop some of the neurobehavioral diseases. That is some of the little work we have done, like Alzheimer's and Parkinson's disease, which will be evident in our population too. So those are the genes, and that is what we are looking for. And this is another key. That is what I talked about, that some of the conditions very important. And if you don't smoking in our area, hypertension, cigarette smoking, and obesity is very high. So, and you see that hypertension is the mostly highly correlated. Our p-value is highly significant, along with the obesity. BMI is in all the population is more than 30. And the cigarette smoking is really very high compared to the overall US condition. So these are the key factors that's kicking up in our area. And also, when we try to project those typical genes in terms of how it correlates with the HbA1c, we see there is a direct correlation. As long as your HbA1c increases, there is a tendency that your gene function is decreased. However, mostly we presented here those all 8, those who are less than significance. I mean, they're more significant. We are trying to get into closer to R, more close to 1, and that could be possible that when we have bigger number of subjects, that is why we are still going on, and your R value will be increased, and you will have a definite trend. Then you can really put into some mathematical condition or any other statistical to correlate the numbers along with the expression values. And that is why we took into another look. We never thought of that. That is what, if you see the slides 2 or 3 ago, that is, we saw that type 2 diabetes might have some neurobehavioral disease. And we thought, we are getting some of the information that type 2 diabetes might have a precursor of Alzheimer's disease at some point. So we talked about some type 2 diabetes and AD and Alzheimer's disease, and we saw that some of the genes correlated are very common, and their expression level is everywhere is very parallel to what you have in the type 2 diabetes and what you have in the AD. And as we search the literature and we look to the other informations, there are some key information or the key pathways. They are very common in type 2 diabetes, like lipid metabolism and others, cholesterol biosynthesis. These are, so basically that in that, on the contrary, we are predicting that if you have those two pathophysiology or the signaling pathways triggering, that T2DM may be a precursor of the AD, or you may get AD earlier than the expected age. It is some of the examples of the same type 2 diabetes in Southeast Asian population, mostly in the Pakistan area that we talked about. And you see that how in that type 2 diabetes Pakistani population, how the sclerosis, Alzheimer's disease is keeping up, and what are the important chemical pathways means, and what are the genes. Red are upregulated genes, and the downs are green are downregulated genes are related, which connect with diseases. And that is a way we can also look into when we get the expression value, and we run the IP analysis too. And it's a global information of the Alzheimer's disease in the position, how it's a complex one. And most of the important like amyloid processing, neuroinflammatory disease, glucocorticoid receptor, Huntington disease signaling, and is coming up. I think it is around 103 genes together. And if you see, if you close just without knowing anything, just if you look at the picture, I mean the gene expression, you will see most of the genes are green, means their functionality is not to the level that you can get protected. So basically, that is a trend. If you have a disease condition, your gene function is not to the normal level, because these are all compared to the normal value or the normal population. So, and majority of them maybe looks like to me, I didn't calculate, but it looks like 90-95% genes are downregulated. It's not going to the normalcy. So with these all informations, what we're planning, what is our next plan? I did talk to Dr. Marwa today morning. So in our population, what we can do, but we have some new stories to come. That is how you can beat dementia. Maybe that I can give an example that I recently visited that part in Delhi. There is an area called Ballabgarh area in the northern India. That population particularly deals with, they do not eat any meat, or they are basically vegetarian, not for a generation, not for a 2 generation, over the period of the civilization when it started, maybe in that area. So basically they are vegetarian by generation, maybe 1,000 years, 2,000 years. And what one of our scientists, they observed that people in that area, they live longer than the usual Indian life expectancy. They are mostly 80 plus, which is very uncommon in India, because Indian life expectancy is now, I think, 68, which is far way below than US. And 2 things he forgot. You see the lifestyle, they eat a low-fat vegetarian diet, and they don't have any stress. That is what I remember. I talked about the stress has to be relieved, and they do not heard about the obesity. What is obesity over there? And their cholesterol level also checked is very low. One of the key things that scientists observed, this is the gene. I think if you have closely looked into that, the network, the ApoE4 gene, that is a gene responsible to get into the risk of Alzheimer's or the Alzheimer's severity, it is somehow not present. Not present means either it is silent or that is being. So we are trying to look at it. What is difference between, because in here we are mostly non-veg and red meat eater, and which is high cholesterol. That is what another area that we can look into. That is what we are trying to find out, whether how diet can make a change in your disease condition, which these people in Ballabgarh is not facing. And if this is true, that could lead a change in the thought. That is what I quote from that gentleman, that life in Ballabgarh could not be different from that complicated and the stressful existence.
It's already 3 and some people.
Okay, yeah, I'm just almost done. So they have something to teach us. So with those, and we are trying a new era of collaboration with Morgan State. We are very much eager to do that one. And we already submitted an RCMI, between 2 RCMIs, one project based on our findings, that if you have type 2 diabetes, you may have to come up with some of the liver diseases. That is how we try to develop, and we have completed some of the work, and we will collect some of the medical records. We will run the high throughput arrays, and Dr. Lee over here will run the mathematical calculation and data analysis. And we expect to have some biomarkers of the liver diseases from the blood work. So basically, it's a development of a blood biomarker of the liver diseases in the future. And with all that said, it is not our work or my work or their work. It is a teamwork. I mean, I feel fortunate that We have a very nice team over here and even abroad. And I'm thankful to everybody. And one of Dr. Mandal is over here with me. And I look forward any questions after that. And I'm happy to see that the new collaboration is coming between Howard and Morgan State. Thank you.
Thank you so much, Dr. Ghosh. And I apologize again for the technical difficulty. And so I would suggest, I have access to the time. I would suggest if people have questions because we're beyond time, could they directly email you?
Yeah, I mean, also, yeah, and one quick thing, they can directly email me and I leave the whole presentation with Nita, and I think I forwarded too. Please feel free to ask this presentation from Marwa or from Nita. So I have the copy, or if you need to contact me, I can also have the copy. Please feel free to ask any questions, any informations about that, or any scientific information.
Yeah, so thank you. So just if you have questions, just can give you his email and just directly contact him. And yeah, so thank you all for joining today, and have a good rest of your day.
Thank you. Appreciate it. Thank you.